Short description. Short description configures scikit-learn's global settings. This provides a concise summary of the function's purpose. It lets users know that this function is designed to modify the global configuration of Pay. Scikit-learn library. Inputs. Inputs. This section lists the parameters the function expects as input. Config dictionary of key-value pairs for configuring settings. This means the function takes a dictionary as input. This dictionary should contain key-value pairs representing the specific scikit-learn settings you want to change. Outputs. Outputs. This section describes the output of the function. None. The function modifies global settings in place. This indicates the function doesn't return any data directly. Instead, it modifies the global settings within the scikit-learn library. Fine-tune parameters. Fine-tune parameters. This section details the specific settings you can configure with the config dictionary. Each entry represents a scikit-learn global setting, including its default value and data type. Assume finite boolean. Default true. Assume that input data is finite. This setting determines whether the library assumes your data is always finite, meaning values don't include infinity or none. Setting it to false can be useful when dealing with datasets where such values are possible, but can slow down calculations. Enable Cythingrad boolean. Default true. Enable Cython gradients for faster computation in some estimators. This setting enables the use of Cython, a language that can make certain computations faster, for gradients within specific estimators. Turning it off might be necessary if you encounter compatibility issues. Enable a stable boolean. Default true. Enable stable AB for compatibility with other libraries. This setting ensures compatibility with other libraries by using a stable application binary interface AB. You might need to disable it if you encounter issues with other libraries. Parallel backend string. Default threading. Parallel backend to use for parallel computations. This determines the method used for parallel processing, e.g., using multiple cores in algorithms. Common options are threading using multiple threads within a single process and low-key using multiple processes. Print changed only boolean. Default true. Print only the changed settings. This setting controls whether the function only prints the settings that were modified, rather than listing all settings. Random seed integer. Default none. Global random seed for reproducibility. This setting allows you to control the randomization within scikit-learn algorithms. Setting a seed ensures that the random numbers generated in different runs will be the same, making your results more reproducible. Reproducibility string. Default 1. Controls the reproducibility of the results. This setting manages how scikit-learn handles the reproducibility of results. Different options might affect things like warnings or how deterministic the algorithms are. Use fast path boolean. Default true. Use fast paths in algorithms. This setting allows scikit-learn to use faster computation paths when possible. It's generally safe to leave it enabled unless you encounter problems. Challenges and fixes. Challenges and fixes. This section outlines potential challenges you might encounter when using Pay function and suggests ways to fix them. Challenge. Incorrect setting values can lead to unexpected behavior or errors. This highlights that using invalid values for settings can lead to incorrect results or errors. Related fixes. Carefully review the documentation for valid settings and their values. It's important to consult the scikit-learn documentation to understand the correct data types and acceptable ranges for each setting. Use appropriate data types for settings. Ensure that the values in your config dictionary match the expected data types of each setting. Challenge: parallel backend configuration can impact performance and stability. The choice of parallel backend can significantly affect how your code runs. Related fixes: choose an appropriate parallel backend based on your system and data size. The best backend depends on your system's hardware and the scale of your data. Ensure that the chosen backend is compatible with your environment. Make sure the backend you choose is installed and works correctly within your environment. Challenge: reproducibility settings can be complex and require careful consideration. Reproducibility settings need careful attention to ensure consistent results across different runs. Related fixes: set a random seed for deterministic results. Using a random seed value can help make your results reproducible. Use appropriate settings for different algorithms and data types. Different algorithms and data may require specific reproducibility settings for reliable results. Carefully manage stateful estimators. Be mindful of estimators that maintain internal state, e.g., some clustering algorithms, as they can introduce variability if not handled properly.